Hey everyone, in this mini lecture we're going to look at the role of alpha within hypothesis testing. So in previous examples of hypothesis testing, you've probably seen that we use that value of alpha, and it's known as the level of significance. So maybe now you might be wondering what impact changing the value of alpha will still have on your hypothesis test. So let's go ahead and take a look. So let's say we make this claim that the average grade for a person using my lecture notes will be more than an 87. So we go ahead and state the hypothesis test as follows. We say H naught mu is less than or equal to 87, and then we'll say H alternative mu is greater than 87. So it would be in my best interest if I could reject H naught, right? Which would then validate my claim. So I can do so by choosing a fairly high value for alpha. Say alpha for us would be 0.10. So this corresponds to a critical z-score of 1.28, right? Because we're using the right tail of a one-tailed hypothesis test. So the critical z-score is 1.28. So let's say that the sigma, right, and this here is the population standard deviation. Sigma is 12, the population standard deviation is 12, and my sample mean, our sample mean for us is 90.6. So this is taken from, let's say, our sample size of 32 students. 32 students. So for this example, the standard error of the mean can be calculated. So we calculate the standard error of the mean. It's sigma sub x bar. It's calculated by using sigma over the square root of n, and sigma is 12, we said, over the square root of 32. So that gets us about 2.12, right? 2.12. So this results in a calculated z-score, and I'm going to come back up to my graphical representation in a moment. The calculated z-score is x bar minus mu sub h naught all over sigma sub x bar. Alright, just plugging in, this gives us 90.6 minus 87 over 2.12, which is 1.70. Alright, so now looking at my graphical representation, we have 0. I just calculated, or actually just came up with that value of the 1.28, right? That was my z critical, 1.28. So that's going to be for us about right there, right? You can use critical z-score calculators online and find that out depending on your alpha. So we have 1.28, and anything in this region here, we would say let's go ahead and reject H naught, right? And for us, this is where alpha, because alpha was 0.10. Anything in the white area is do not reject H naught, right? And this is 0.90. We have that from 1 minus alpha. Alright, so we just calculated this 1.7. The 1.7 is about right here, over to the right of 1.28. So that's our z sub c. And you see how that falls in the reject region. So according to this figure, I've achieved my goal of rejecting H naught because the calculated z-score is within the shaded region, right? It's within that shaded region after above my 1.28, that critical z-score. It appears after that inside of that shaded region. So the notes appear to have done the trick. So what I just did previously, I chose a z-score, I chose an alpha of 0.10, right? So this was in an effort to help prove my claim. So in this case, I'm willing to accept a 10% chance of a type 1 error. So a better test would be able to set alpha lower, right? So maybe say, let's set alpha to be 0.01 this time. So now that's an even better alpha for us. So the level of significance corresponds to a critical z-score of 2.33, right? That corresponds to that. And again, you can use your online critical z-score calculator and that value will just pop up. Or you could go ahead and use a table if you prefer and work through getting that value. So let's go ahead and look through this. So here is 0, 1.7, so again right there, that's the value. This is 0.99, it's my rejection region, where we say let's reject H naught, and here alpha is 0.01. This 0.99 is from 1 minus alpha, and we say do not reject H naught. Alright, so that 2.33, and I'm sorry, I kind of need to redo these here. The 2.33 is right there, right? Makes more sense. And now our 1.7 is right there. Alright, so the level of significance corresponds to a critical z-score of 2.33. So this shows the impact of this change, this graphical representation here, because as you can see, the shaded region here no longer includes my calculated z-score of 1.7. So therefore, now I do not reject H naught and cannot claim the average grade of those using my notes will be greater than an 87. So in general, a hypothesis test that rejects H naught is most impressive with a low value of alpha.